Have you ever wondered what the future holds? Not just tomorrow or the next year, but the distant future, all the way to the end of time itself. Time, a concept that has puzzled scholars, philosophers, and scientists alike for centuries. It is the constant drumbeat that underlies our lives, a flow that carries us from the cradle to the grave. But what is time, really? Is it a river carrying us inexorably forward? Or is it an illusion, a construct of the human mind? In the vast, uncharted territories of the future, time takes on a new dimension. It is not just a measure of moments, days, or years, but a canvas upon which the story of the universe unfolds. From the birth of stars to the death of galaxies, from the formation of planets to the extinction of life, time is the silent narrator that tells the tale of everything that ever was, is, and will be. As we stand on the precipice of the future, we look to the theories of cosmologists and physicists for guidance. They speak of time not as a straight line, but as a curve, bending and twisting under the weight of the cosmos. They talk about black holes, where time slows down to a crawl, and the Big Bang, where time and space were born in a fiery explosion. And then there's the end of time, a concept so mind-boggling it defies comprehension. Will the universe continue expanding forever, growing colder and darker until the last star fades away? Or will it collapse in on itself, time and space folding into a singularity, a point of infinite density where the normal laws of physics no longer apply? As we embark on this journey to the end of time, we must first understand what time is and how it shapes our existence. It is a journey not just through space, but through the very fabric of reality itself. A journey into the heart of the greatest mystery of all, the enigma of time. Time, in the cosmic sense, is an ever-ticking clock, a relentless force driving the universe towards its destiny. In the vast expanse of the cosmos, time unfolds on a grand scale. It's not just seconds, minutes, and hours we're talking about. Rather, we're dealing with epochs and eons, periods so vast that they boggle the human mind. Let's journey back to the very beginning. Roughly 13.8 billion years ago, the universe as we know it burst into existence in an event we call the Big Bang. In that moment, time and space were born and the cosmic clock began ticking. The universe started as a hot, dense point of singularity. But as time ticked on, it expanded and cooled, giving birth to stars, galaxies, and eventually our own solar system. These cosmic events, from the violent birth of a star to its quiet death, serve as milestones on our cosmic timeline. They are the hands of our cosmic clock, marking the inexorable passage of time. Each star that flares into existence, each galaxy that spirals into formation, is a testament to the relentless march of cosmic time. Consider the life cycle of a star. It begins as a cloud of dust and gas, slowly coalescing under the force of gravity. Over millions of years, the pressure and heat at its core ignite nuclear fusion, and a star is born. This star may burn for billions of years, but eventually it will exhaust its fuel. Depending on its mass, it may collapse into a white dwarf, explode as a supernova, or even form a black hole. Each of these events is a tick on the cosmic clock. As we observe the universe, we're not just seeing space, but time. We're looking back at light that has traveled for billions of years to reach us, providing a glimpse into the universe's past. But what of the future? Well, that's the grand question, isn't it? The universe continues to expand, galaxies drift apart, and stars burn out. We're part of an ongoing cosmic story, a narrative written in the language of time and space. As we move forward on this cosmic timeline, we venture into the unknown, into the future that awaits us. Our journey takes us first to the future of our own planet, Earth. As we look ahead, we delve into the realm of scientific predictions, a fascinating and often sobering exploration of what lies ahead for our home world. In approximately 5 billion years, our sun will exhaust its nuclear fuel. As it dies, it will swell into a red giant, engulfing the inner planets, including Earth. This celestial event, while distant, serves as a stark reminder of our planet's inevitable destiny. But what of life on Earth? The concept of a post-human world is not only possible but likely. As the sun's luminosity increases, the Earth's climate will drastically change, becoming inhospitable for most forms of life. Over time, the oceans will evaporate, the atmosphere will change, and the last vestiges of life will disappear. The Earth, as we know it, will cease to exist. Yet, it's important to remember that this is not a tale of doom and gloom. It's a testament to the incredible journey of life and the resilience of species to adapt and evolve. It's a story of cosmic cycles, of stars born and dying, of planets evolving and changing. In the grand scheme of the cosmos, our existence, as fleeting as it may seem, is a part of this incredible cosmic dance. We are, after all, made of star stuff, born from the heart of a long-dead star. Our fate is intertwined with the fate of the universe, and in that, there is a strange kind of comfort. The future of our planet, while distant and different from what we know today, is a part of the natural processes of our universe. It's a reminder of our place in the cosmos, a humbling perspective that underscores our responsibility to cherish and protect our home for as long as we can. The fate of our planet is a sobering reminder of the transience of existence, a testament to the relentless march of time. As we journey further into the future, we witness the end of stars, the cosmic beacons that have illuminated the universe for billions of years. The enchanting glow of these celestial entities is not eternal, but a fleeting sparkle in the grand cosmic ballet. Every star, from the tiniest red dwarf to the largest hypergiant, follows a life cycle. Born from the dense, swirling clouds of dust and gas, stars spend most of their existence fusing hydrogen into helium in a process known as nuclear fusion. This is the stage we're most familiar with, the stage our sun currently resides in. However, as the hydrogen fuel depletes, stars begin their journey towards the end. Larger stars explode in spectacular supernovae, scattering their enriched guts across the cosmos, seeding the universe for the next generation of stars and planets. What remains collapses into a dense neutron star or a black hole, depending on the star's initial mass. Smaller stars, like our sun, follow a more peaceful path. They swell into red giants, shedding their outer layers and eventually dwindle down to a white dwarf, a hot, dense core. Over unimaginable spans of time, these white dwarfs cool and fade, becoming black dwarfs, barely detectable against the black canvas of space. Imagine, if you will, a universe devoid of stars, a cosmos plunged into darkness, populated by black dwarfs, neutron stars and black holes, cold, quiet and incredibly vast. This is the future that awaits us, a starless universe. However, this is not a cause for despair. Instead, it is a testament to the transient nature of existence. The life cycle of stars reminds us that change is the only constant and that endings are but precursors to new beginnings. The end of stars marks a significant point on our journey, a point where the universe as we know it ceases to exist. At the farthest reaches of the future, we encounter the end of time itself. This is not a mere cessation of clocks or calendars, but a fundamental shift in the fabric of reality. Here, the very concept of time as we understand it may cease to exist. We look to cosmology, the study of the universe's origin, evolution, and ultimate fate. To shed light on these enigmatic possibilities, there are several theories about how the universe and consequently time might end. Firstly, there's the Big Crunch, a scenario where the expansion of the universe eventually reverses. This would cause everything to collapse back into an infinitesimal point, a singularity similar to the one from which the universe purportedly sprang during the Big Bang. If this were to occur, time as we know it would cease, as everything, including time itself, would be compressed into this singularity. Then there's the Big Freeze, an idea based on the continued acceleration of the universe's expansion. In this scenario, stars would burn out, galaxies would drift apart, and the universe would become a cold, dark, and desolate place. Time would still technically exist, but without any events to mark its passage, it might as well not. Lastly, we have the Big Rip. This is perhaps the most dramatic of the three. If the universe's expansion continues to accelerate, it could eventually tear apart galaxies, stars, planets, and even atoms. Time might still tick on, but with no matter left in the universe, it would be a rather moot point. Yet it's important to remember that these are just theories, and our understanding of the universe is continually evolving. We might never fully comprehend the nature of time or its ultimate fate, but the pursuit of these answers, the quest to understand the cosmos, is part of what makes us human. The end of time is the ultimate frontier, a realm beyond comprehension, signifying the end of our journey. From the enigma of time's inception to the cosmic clock's relentless ticking, our journey has been one of awe and humility. It reminds us of our fleeting place within the cosmic order, inspiring us to cherish our time and use it wisely.